Hello, today we're going to be working at basically classification of rigid motions. So over here you should be looking at several different things. So you should be thinking about what we're going to be talking about today. There will be no note page today. It's kind of like in a sense of a mini review. It's slightly different, but not that much. So if you're looking around, you should be seeing that there's a lot of different things in real life that you see here. For instance, you see that, well, the baseball has same kind of pattern, stitching pattern on both sides. That's one thing you can kind of see. Another thing you should be probably seeing is the fact that a lot of plants have the same pattern going back and forth, and also footsteps in the sand, petals of a flower, things like that. There's a lot of weird similarities here. Okay, so they're not too weird actually. It's part of nature. All right, so let's carry on. You should be seeing like a lot of similar patterns with this. Let's carry on, shall we? I'm on the wrong page, so let's make sure I'm on the right page. Click over here. So we're going to be talking about the classification of rigid motions, along with it's going to be similar to what we were covering on a couple days ago, but also glide reflection. So we can carry one given figure to another. So we're going to geometric descriptions to rigid motions to transform figures as well. So for the warm up, you already did that vocab. We have that discussion. We'll go through this. So review vocabulary is reflection, rotation, and translation. The newest one for today is glide reflection, and it's simply think of like walking feet. When you're walking, you're actually doing a glide reflection as you go one foot forward in front of the other. And there's plenty of examples of this in nature. Okay. A composition of two or more rigid motions is a rigid motion. So if we are preserving, if we have basically we want to preserve the angle measure and the side lengths for it to be rigid motion. And as we get more and more of those things, it's still going to keep. So we already lightly talked about this in the past. So if you see here, we have that same little pattern, that little dot, which is the composition. So we just need to make sure we are going from this side to this side. That means it goes from here, it reflects, and then it looks like it does a rotation. Okay? So the question is, how is the final form created? It's created by a reflection followed by a rotation. All right. We're going to assume the order does not matter. This is going to be why order does matter. So we're going to perform the following translations on the line. We're going to translate and then rotate. The wrong way would be to rotate and translate, but we should be translating then rotating. So you're going to see two different examples. The wrong way, we're going to rotate first, then we're going to translate. So you see how the red was going the wrong way. The correct way, we're going to translate first, then we're going to rotate. So you see the difference in which way we're going. That's why it kind of matters. There's only very special cases where it doesn't matter, but often you'll have to run into a case like this. Or in completely different areas, it looks like we might be lined up properly, as you see. We're lined up perfectly properly, because you see over here we have A prime way over here, double prime at -6, but where it should be is at 0, 0, or the origin. So the whole thing is just shifted over by 6 units to the negative direction by going the wrong way. So that's why we have to be very, very careful and pay attention to the number of prime, basically ticks we have to see what we have. Because we could have something like this. Is there a transformation that maps only one transformation? Notice that we only have one tick mark on the orange A, B, and C. There's only one tick mark here, here, and here. So that tells us that we only have performed one transformation, not two, one. So there's what one transformation will map to. We can't reflect because a reflection would only pop it right over here or down here. And if we're trying to reflect like y equals x, it wouldn't be in the same direction. It would be on its side because the fact that b is on the top, in order to do the reflect, it would have to be over here or b would be down here. So the closest thing we could do is just a reflection, say over here somewhere. Get us over there. 1, 2, 3, 4, 1, 2. So the reflection we would want to have at -1. We'll put b right up here, and that's the problem. A rotation would make it so b is done on top. In a translation, we can get B and C in the correct spot, but A would be in the wrong spot. So we can't do that either. So we're out of options of what we know at this point. So let's go ahead and look at the new aspect, which is the glide reflection. So we're looking for a translation that maps E to P prime. And a reflection in line K, basically line of reflection, parallel to the direction of the map P to P prime. So it's like walking, put one foot in front of the other. You have this invisible line you're kind of following unless you're walking all crazy like. So that's what we have here. We slide and then reflect, or reflect, then slide. They're interchangeable because you can walk backwards, so this step is interchangeable. All right, so let's revisit this one. Notice A flip sides, B counts, flip sides, count B points in a line to the other, then count back. And adjust them accordingly. In this case, we're going to be looking at it negatively. So B, starting down, we're going to have this kind of composition right here, which is a glide reflection. If we look here, we're trying to get down to here. 1, 2, 3, 4, 5, but we're decreasing by that 5, so that's a -5. So as we saw, that x is -1 for the line of reflection, but then we have to decrease only basically vertically by 5. So there's our line of reflection. As you saw, we counted out by 4, went back 2, and just get that line of reflection. Now, we reflect it over and take that image and slide it in, and we decrease it by 5 and slide down into place. So, a second example. What we have here, is determine the glide reflection for the following image. It looks like a Tetris block on purpose. So we have to find how we got here. So we always want to try to start with something we can see. For instance, C and C prime. Like B and C move up. So we want to look at B and C move up from 4 to 0, and 4 divided by 0 is 2. So B and C move up from here, 1, 2, 3, 4. Divide that by that, we have 2. So we go back by that 2. So we decrease it, so we have y is equal to -2 as our line of reflection. So how do we then get to the points over to where they're supposed to go? We simply count to adjust. C, for instance, needs to get over here to right here. 1, 2, 3, 4, 5, but we're moving in a positive direction. So when we flip the shape over, we get that. And now we need to move over by that positive 5. So combine what we know, we have that positive 5 and y is equal to -2. So translation and rotation. Which is the correct transformation for this? Give it a shot, and we'll go from there. So give a pause, give it a shot, and we'll go from there. Welcome back. So if you're looking at this, notice that these two flip sides. A needs to flip over, but A stays on top. So that tells us we have a line of reflection around here somewhere. It's going to be at x equals something. So we can eliminate right now. We can just say we don't need this one because it says y is equal to 4. So now we need to figure out which one of these actually fits the bill. if we're going back to having a look at what we have here for, we have 1 right here. 1, 2, 3, 4. 4 divided by 2 is 2. 1, 2. Notice that this is a 3. So anywhere that's not a 3, we can now eliminate because we don't need that. That's gone. That's gone. So which ones are left? 5, 0 or 0, 5? So now we need to pay attention to how we're translating. Are we moving up? Are we moving to basically y up? Or are we moving x up? Okay, well, it looks like that A is definitely moved up, so that would eliminate this one because this is saying X is moving up, so it has to be that one. So let's see what happens. We have that line of reflection. Okay, and then we're moving up. So we have to say that it is in fact that one. Pretty simple, pretty straightforward. All right, you guys are welcome to have a look at the page number, which is going to be on the board as well, for what we're going to be doing today. There is several problems, but it's also going to be online as well. Have a nice one now.